Okay, welcome back. In this video, we are going to look at a refresher in terms of scientific notation. Now, scientific notation is very simple. It is a notation used to write very large or extremely small numbers as condensed as possible. And we use scientific notation in conjunction with exponents. So, scientific notation is talking about this piece here, the times 10 to a power. So what we do with it, or the easiest way to do it if you want to go back and forth, is I would take the decimal that I have and I would rewrite it out. So this was 8.35. And then the exponent here is going to tell you how many places to move the decimal point. And then the second thing to notice is the sign here tells you, so your sign gives the direction. So your exponent is going to tell you two things. And so here, this was -3. So when we're talking about negative, okay, first thing we need to remember is that negative means we're going to move left. Positive means we're going to move to the right. What I like to think about it is moving left means that the number is getting smaller. Moving right means we are getting larger. Okay. So here, notice this is my decimal point. It's sitting right here. And I have to move 3 places to the left. So we're going to play hop, skip, and a jump. So this goes 1, 2, 3. And we input the decimal there. Now what you need to do is you need to fill in the empty places with zeros. So 0 goes out in front, and then 0, 0. So if you notice, I have 3 zeros here. I had a 3 is what I had to move, and then here's my number. So the actual number here that we're looking at is 0.00835, and this would be the answer that we are looking for. So let's look at another one here. Okay, so again, if I'm looking at my decimal, some things that you need to keep in mind is that this is positive, so this means we are going to move to the right. And then I'm going to move 5 places. So I'm going to start with my decimal. So I have 4.2. And I'm going to move. So we're going to move to the right. So this is 1, 2, 3, 4, 5. And I would put the point. And then I need to fill it in with zeros. So here we go. There's a blank, 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 blank. And of course, we could put 0.0 on the end. But essentially here, what we're looking at is we are looking at 420,000. And this is our result. So this is looking specifically at what we like to call decimal form of scientific notation. So again, let's look specifically one more time at how this actually works. So again, scientific notation is a notation that is used in order to write very large or very small numbers in a very condensed form. So in other words, the scientific notation part is where we are talking about times 10 to a power. That is the scientific part. Now, the other thing that we're looking at is how to put it together. So the biggest thing you have to keep in mind is when you are going into scientific notation, you need to place your decimal point so that your end result is a number between 1 and 10. The biggest hint that we have here is that means you are placing your decimal point between the first two non-digit numbers. And then you have to multiply by 10 to a power, and the power is determined by however you moved. Okay? So, what are we trying to get at here? If I have 8,720,000 and I want to write that as decimal notation, the first thing that I have to do is identify that decimal point. When you're dealing with a whole number, your decimal point is going to be at the very end of the number. Okay? The next thing you have to do is you have to jump your decimal point, in this case to the left, until we have a whole number that falls between 1 and 10. So notice here we are jumping that decimal between each number until we get to a number that's less than 10. So here obviously 8 would be less than 10. You need to count the total number of jumps you made. So we've got 1, 2, 3, 4, 5, 6. So we made 6 jumps. This is going to tell you your exponent. Okay? So here you would rewrite your final result showing all of the non-zero digits, so 8.72, and then it goes times 10 to the power of 6 because this is the number of jumps. So here your 6 or your exponent represents the number of jumps. Okay. When we are talking about this 10 piece, this is the scientific notation. Okay. Alright, so let's look at a couple examples to see if we can do it on our own. So again, we want to write in scientific notation. So here, the first thing we need to do is identify where your decimal is. So there's the decimal. So we have 376,000, and here's my decimal at the end. So I have to jump it. I'm going to move in this direction because I had a large number. And I'm going to come all the way over until I reach here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. And this is where the decimal is going to go. So here what we're left with is we are left with 3.76. And then we got to do the scientific notation part. So this is going to become times 10. And then again, how many did we jump? Well, we jumped 1, 2, 3, 4, 5, 6, 7, 8. So this becomes an 8. Okay. Now again, the reason this is positive is because we started with a really big, large number. So a large number means that you have a positive exponent. Now let's look at this other one. We have 0.0362. So again, we need to be able to jump, but in this case we are going to go in this direction. And we don't have to go very far because we just simply have to get to where we have a whole number between 0 and 10, or 1 and 10. So we have 1, 2, and there we go. So this is going to become 3.62. 2. And then again, we have to do the scientific notation. Times 10. We jumped 2 places. Because we had to move it to the right, this is going to be a negative 2. Okay. So here, what we need to remember is that if you have a decimal, then that means you have a negative exponent. Now, there's more that we can do than just simply identifying numbers. We can actually do calculations. In order to do calculations with scientific notation, the first thing you need to do is write all values in scientific notation. So we have, if you look at this first example, I've got these 2 values here, so I need to write each of them in scientific notation. So I have 0.0003. Again, I'm going to move it. So 1, 2, 3, 4. So this is going to become 3.0 times 10 to the negative 4. And now I have to do the other. I have 0. And I've got 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 25. Again, find the scientific notation, so move it. 1, 2, 3, 4, 5, 6, and 7. So this one is going to become 2.5 times 10 to the negative 7. Once you get both of them written into scientific notation, we can then set it all up to do the math. So here we have 3.0 times 10 to the negative 4. And we're going to multiply this by 2.5 times 10 to the negative 7. So the rule that we need to do is this. You want to combine your whole numbers first. So this is going to be 3.0 times 2.5. We then have times 10 to the negative 4th and 10 to the negative 7. Right here we have a product rule. And then we would actually do, for right here, this first part, or the whole number part, you would do normal multiplication. So we would have 3 times 2.5. So this is going to give us 7.5 times 10. And then negative 4 plus a negative 7 is negative 11. And this would be the result we're looking for. Alright, let's do it again. So here, if we look at our first number that we have is 0.0046. Again, we gotta do 1, 2, 3 is where we go. So that means this is going to become 4.6 times 10 to the 123. So negative 3. And then I have the number 230. If you remember, that means my decimal point is here at the end. So we're going to jump backwards. 1, 2. So this is going to be 2.3 times 10 to the 2. I need to set it up. So this is again 4.6 times 10 to the negative 3 divided by my 2.3 times 10 squared. Again, we're going to look at just the PowerPoint, as well as we're going to look strictly at the whole number piece. So here we're actually going to do 4.6 over my 2.3. But then what we need to keep in mind here is that this one, no matter what, has to come upstairs. So 4.6 divided by 2.3 is going to give us 2 times, and this is going to be 10 to the negative 3 minus 2. So here we're going to end up with 2.0 times 10 to the negative 5. Alright, let's take a look at one that's a little bit more complicated than what we just did. Essentially what we're doing here is we are going to sandwich the two ideas from those first two examples together. So the way that you want to work it is you want to work just your tops, then just your bottoms, and then combine. So the first thing we're going to look at is we're going to look at just the numerator. So when we're looking at the numerator, we need to combine 1.4 times 10 to the negative 2 and 922. So here the only one that has to change is going to be 922. So here I've got 922. Here's my decimal. Again, I need to move it, so 1, 2, puts it right there. So that makes this 9.22 times 10 to the square. So that is going to change my numerator here to being 1.4 times 10 to the negative 2 times 9.22 times 10 to the squared. Again, the rule says combine your your numbers, 1.4 times 9.22, and then we're going to combine scientific notation. So times 10 to the negative 2, 10 to the square. So here this is going to be 12.908 times 10 to the 0. And so at the moment I would leave this as is, and I would now work with the denominator. So the denominator, again, we've got 3.5 times 10 to the third times 2.0 times 10 to the 6th. So both of these are already in scientific notation. So we can skip right to combining. So combining says, first again do your numbers, so 3.5 times 2.0, and this is going to be times 10 to the third and 10 to the 6th. So we have my 3.5 times 2 is going to give me 7. So this is 7.0 times 10 to the 3 plus 6. So this is 7.0 times 10 to the 9th. So we have new top and new bottom. So we need to rewrite to see what we have. My numerator was 12.908 times 10 to the 0 divided by 7.0 times 10 to the 9th. So again, one of the things you have to remember is that my denominator has to move up to the top. And so here we're going to have 12.09 divided by 7, which is going to give us 1.844 times 10 to the negative 9. Why? Because 0 minus 9 is negative 9. And this is one of the reasons why I left this 10 to the 0 in, is so that we can do the math here. 0 minus 9 to move it up. Okay? But this then is the overall result of what we were looking for. So there you have it, a refresher in scientific notation, in terms of calculating scientific notation, switching back and forth between scientific notation and its decimal form, and then being able to combine or perform some calculations with them. So if you have any questions, please let me know. Otherwise, have some fun, enjoy your math, be creative, and I'll see you next time.